Join me as I put different materials to the test and see what really happens when thermal energy hits them. Thermal energy is all around us. It's the energy that comes from heat, and it's something we experience every day. From the warmth of the sun on our skin to the heat from our stovetops, thermal energy plays a huge role in our daily lives. Understanding how different materials respond to thermal energy can be a bit tricky. Some materials seem to handle heat really well, while others can get damaged or even change shape. This is super important when it comes to designing and building things, like electronics or even just a simple wooden chair. If you don't know how a material will react to heat, you could end up with a big problem on your hands. So let's dive into the science behind thermal energy transfer. There are three main ways that thermal energy can move from one place to another: conduction, convection, and radiation. Conduction is when heat moves through a material, like a metal spoon getting hot when you hold it in a cup of coffee. Convection is when heat moves through fluids, like when you boil water and it starts to circulate. Different materials react to thermal energy in really different ways. Metals like copper and aluminum are great at conducting heat, which is why they're often used in cookware. Wood and plastics, on the other hand, are much poorer conductors, which is why they're often used in handles and grips. When it comes to radiation, some materials can absorb heat really well, while others can reflect it. One really cool example of thermal energy in action is what happens when you heat up a bimetallic strip. These strips are made from two different metals that are bonded together, and they have different rates of expansion. When you heat them up, one metal expands more than the other, causing the strip to bend. This is a great example of how thermal energy can cause materials to change shape. To sum it up, we've learned that thermal energy can have a big impact on different materials, causing them to change shape, expand, or even change state.